Okay, so what we're going to do are two exercises here. The first one is we're going to try work out a name from a formula, and the second one we're going to try to write formulas from the names. So we have some rules. The first part of your formula, or the first part of your name, if it's a metal by itself, it stays the same. Or is it a transition metal? And if that is the case, we need to include Roman numerals for its valency. So we're going to be using the drop up diagram for this. Or is it a complex cation? And that's something that you have to learn. So you need to know the formula and the charge to be able to use it. The second half of our compounds you're looking for, is it just a non-metal? And is it just one non-metal? And we know from this that if that is the case, we're changing the ending of the name to IDE. The other part that we need to know is it a complex cation? A complex anion. And the giveaway here, it'll be two non-metals. That's going to be your giveaway. And again, these are things that you have to learn, both charge and name. So we know what our rules are. We're now going to have a look over here. So we have NH4Cl. So in terms of our rules, this here is a non-metal, just one of them. So, and it's chlorine, so we know chlorine will become chloride. And this here, it's two non-metals. It is a complex cation. So again, this is one you just have to learn and know. So when we put those together, it's going to be ammonium chloride is the name of this particular formula. Our next one is Fe bracket NO3 three times. So straight away, the bracket, the fact that this is two non-metals, this is a complex anion. Over here on the other side, we have iron, and this is a transition metal. So this is going to be variable valency, so we have to figure out what that is. So this is going to be our drop up. One of the things you have to recognize here is that NO3 is a negative charge, and we have three of them. So when we are dropping up, we are doing a little multiplication first, so it's going to be a 3 by 1, and when we drop up, this is going to be a 3. Okay, so when I put the names together, the Fe is iron, Roman numeral 3, and the anion is a nitrate. So iron 3 nitrate, and in my mark schemes you'll see a tick and a tick for this, because one for the Roman numeral and one for the name. We're going to look at titanium, Br3. So titanium is a transition metal, so we have to figure out its valency. And Br is one element by itself. It's a non-metal. It's in group 7. So straight away, when we do our drop up, we know that this is going to end in a bromide. It's going to have a titanium in it, but we need to figure out what the charge is on this. So we're going to use our drop up with Br3, and in this case the only thing we need to drop is this 3. There's a -1 here, so if we do a multiplication, 3 by -1 is 3, so it's going to be a +3, so then our name becomes titanium 3 bromide. And again, if you look at my mark schemes, you'll get a tick and a tick. Our next one that we're looking for is Cu3p. So again, what am I looking for? Here, it's just an element by itself. It's a non-metal. It is phosphorus, which is in group 5. So it is going to be end in a phosphide when we get there. This copper is a transition metal, so it's going to have variable valency, so we need to figure out what that's going to be. So it's going to be a Cu and it's going to be a P, and we know that there's one here and that this one is going to go up even though it's not shown. So this name of this particular compound becomes copper 1 phosphide. Our next one is going to be a PbSO4 twice. So Pb is a transition metal, so it's going to have variable valency, Pb being lead. Inside our brackets, we know we have a complex anion. It is a sulfate, and this sulfate, when we put it into our drop up, is going to be a 2 negative charge overall. So we do have to know this. So we're doing a little multiplication in our head. 2 by 2 is 4, so we're dropping up a 4 here, and this becomes lead 4 sulfate. Our next one that we're looking at is BeHCO3 twice. So we know this is just a metal and it's from group 2, so it's just going to retain its name, no variable valency, so it's going to be beryllium. We know that here in our bracket this has to be a complex anion, and that complex anion is a hydrogen carbonate. So we don't have to worry about variable valency, we just write it as beryllium hydrogen carbonate. So again, on one of my mark schemes, that will just give you 1 tick because we didn't have to do anything else to it. We then have Mn2SO3. So I'm going to put this over here, Mn2SO3, and that is 3 times. So what we are going to also, I'm just going to write the other one while I remember it in my head. So what are we looking at here? This is a transition metal, so it's going to have variable valency. This is a complex anion. It is a sulfite. So we're going to have to do our drop up. So we have Mn2SO3, and this is going to be 2 minus. So 2 by 3 is 6 is what we're going to drop up. Okay, so this becomes a little multiplication. So when we write the name of this, it's going to write as manganese. So note it's not magnesium. Magnesium 6 sulfite. Our last one at the bottom, Al, is just a group 3 metal, so the name stays the same, no variable valency, no complex cation, so it's just going to be aluminium. Here we know if it's in a bracket, it is a complex anion. This is cyanide, so this is all we would write, aluminium cyanide. Okay, so the ones with the complex are a little bit, there's a little kick to them. You just have to recognize what is the charge on your complex cation, as in over here. And if there is a multiple outside your brackets, you are multiplying the multiple by the charge to figure out what the drop up is going to be. Okay, so the next one is writing formulas from names. So this is using our drop-down method. So in number 11, we have chromium, it's telling us, and the Roman numerals tells us the charge, and that makes it a 6+. The phosphate is a complex anion, so you have to learn it. It is a 3-. We are doing our drop, and the thing we are dropping down is just the number that is in the charge. So that makes it a 3 and a 6. We go for the simplest whole number ratio, which is the same as a 1 and a 2. So when we put it all together, it's CrPO4 in brackets twice. Our next one is vanadium carbonate. So again, it's telling us in our vanadium that it is a 4+ charge. So I'm getting that from the Roman numeral in the name. And a carbonate is a complex cation, and it's CO3 2-. So again, my drop down is going to be looking at this 4 and this 2. So 4 and a 2 is essentially the same as a 2 and a 1. So when I've written that wrong, haven't I? Okay, we just get rid of this part and we speak again. So when I drop down, I'm dropping down a 2 and a 4, which is simplest ratio is a 1 and a 2. So this becomes VCO3 in brackets, and there's 2 of them. Now, the next one we're going to look at is the tin 2-nitride. So tin is SN. The Roman numerals tells me it's 2+. Nitrite is NO2-. So again, we infer 1 in chemistry. It's never usually written. So our drop down here is a 2, our drop down here is a 1. So now I put it together, SN, NO2 in brackets, and I have 2 of these. We're going to 14, which is cobalt 3 according to the Roman numerals, so that's going to be a 3+. Oxygen is just a group 6, so we know if you live in group 6, you have a 2- charge. Our drop down is going to be the 2 here and the 3 here. Can't make those numbers any simpler, so we have a CO2O3 as our name here. 15 tells us this is chromium, and it has a 3+ charge according to the Roman numeral. Hydroxide is a complex anion, so you have to learn. Again, the 1 isn't inferred, but it is. These are the numbers that I'm dropping down. So we have a 1 and a 3. And then we finally put it together, CO, and I now have 3 OHs in brackets. On to 16, we have lithium iodide. So lithium is a group 1 metal, so it's going to have a 1 positive charge. Iodide is group 7, so we know that's going to be a 1 negative charge. So these are the numbers I'm taking for my drop down. It's a 1:1, so I just write L small I big I for lithium iodide. For our lead nitrate, so lead is a Pb. My Roman numerals tell me it's 2+ charge. Nitride is just the element. It's not a nitrite or a nitrate. So this lives in group 5, which means it has a 3 negative charge. These are the numbers that we're dropping down. So it becomes Pb3N2 as our formula. And the last one is silver bromide. So silver is Ag. There's no Roman numerals in it, so it's going to match the charge of what my bromine is. My bromine is group 7. Group 7 has a -1, so this must mean this must be a +1 because there's no Roman numerals to tell me that my transition metal has any variable valency. And when I get these together, if it's a 1:1, it becomes an AgBr.